job 3 machines. So what is the case for n job 3 machine, that we'll try to understand. So number of jobs, that are n1, n2, n3, n4 and so on. Number of machines are 3, that is m1, m2 and m3. Now suppose order of processing on machines is, firstly we'll perform a job on machine 1, secondly we'll perform on machine 2 and then we'll perform job on machine 3. To solve problem on n job 3 machines, we have to check initially some conditions. So conditions to be checked. So very first case, that is first condition, smallest processing time of any one job on the machine M1 is greater than or equal to the maximum processing time of any one job on machine M2. So this is the first case we have to check. Let's see case number 2. It is smallest processing time of any one job on machine M3 is greater than or equal to maximum processing time of any one job on machine 2. So in case number 1, we are finding the smallest processing time of machine M1 and we are comparing it with the maximum processing time of machine M2, and in case number 2 we are finding the smallest processing time on machine M3 and comparing it with the maximum process time of machine M2. So both the cases, smallest processing time of machine M1 and M3 is to be compared with the maximum processing time of machine M2. Now see, if any one condition is satisfied, then we can convert 3 machine to 2 machine for finding the sequence of operation. That means in any of the case, right, case number 1 or case number 2, any of the case satisfies the condition, then we can convert 3 machine problem to 2 machine problem to find out the sequence of operation. So to find the sequence of operation, we will consider 2 machines, right? Separate 2 machines we will consider as machine G and machine H. Now we'll find out the processing time of machine G. How to find it? Processing time of machine G is equal to processing time of machine 1 plus processing time of machine 2. So we'll go for this step only if any one of the case matches. Then to find the processing time of machine H, we'll have a processing time of machine 3 plus processing time of machine 2. So in this way we will convert 3 machine problem into 2 machine problem to find out the sequence of operation. This we'll try to understand with one example. To solve this problem, we have to convert the processing time of 3 machines to processing time of 2 machines. For that purpose, we have to check the conditions we have discussed earlier. So write down first minimum process time of machine 1. Minimum process time of machine 1, that is, if we look at the process time of machine 1, the minimum value is 7. Then maximum process time of machine 2. So maximum process time of machine 2. So maximum process time of machine 2 is 6 hours. So I'll write 6 over here. Then minimum time minimum process time of machine 3. So minimum process time of machine 3 is 4 hours. After writing this, we have to check the conditions. So our first condition states that the minimum process time of machine 1 should be greater than or equal to maximum process time of machine 2. So for our case, our minimum process time is 7 hours, which should be greater than or equal to maximum process time of machine 2. So maximum process time for machine 2 is 6 hours. So if we compare 7 hours and 6 hours, 7 hours are greater than 6 hours. So our first condition matches. Then our second condition states that the minimum process time of machine 3 should be greater than or equal to maximum process time of machine 2. So for our case, it is the minimum process time for machine 3 is 4 hours and maximum process time for machine 2 is 6 hours. But our second condition does not match. Condition 2 fails, but condition 1 matches. So if any one of the condition from 1 and 2 matches, then we can move forward for the solving the problem. Now let's see how to convert this 3 machines processing hours into 2 machines processing hours. To convert 3 machines processing hours into 2 machines processing hour, let's consider a new machine, that is machine G, which will be the combination of processing hours of machine 1 and machine 2. So I'll write machine G is equal to machine 1 plus machine 2, and another machine, that is machine H. So machine H will be processing combination of processing time of machine 2 and machine 3. So I'll write over here machine 2 plus machine 3. Now we'll represent this processing hours of machine G and H in tabular form. To do this, draw a table like this. In first column, we'll write machines. So machine G, which will be a combination of machine 1 plus 2, and machine H will be combination of machine 2 plus 3. Here I'll write number of jobs, that is A, B, C, D, E and F. So this is the extra column. Now machine G processing time will be the combination of machine 1 and machine 2. So that is, for job A, machine 1 will take 12 hours and machine 2 will take 6 hours. So combination of machine 1 and machine 2, that is 12 plus 6. So 18 hours. Similarly for job B, it is 10 plus 5, that is 15. Then for job C, it is 9 plus 6, that is 15. For D, it is 14 plus 4, it is 18. Then for E, 7 plus 2, that is 9. Then for F, it is 9 plus 4, that is 13. Similarly for machine H, it is the combination of machine 2 plus machine 3. For job A, machine 2 takes 6 hours, machine 3 takes 7 hours. So 6 plus 7, that is 13. Then for job B, it is 5 plus 6, it is 11. Then job C, 6 plus 6, 12. Job D, 4 plus 5, that is 9. Then for job E, it is 2 plus 4, that is 6. And for job F, it is 4 plus 4, that is 8. So this is the conversion of 3 machines processing time into 2 machines processing time. Now by using this table, we'll find out the optimum sequence of operation that will give us a total minimum elapsed time. So let's find out the sequence of operation by referring this table. To find the sequence of operation, we'll draw a 6 blocks for our 6 jobs. On the left hand side of this block, I'll write machine G, and on the right hand side of this block, I'll write machine H. Now to find this sequence, find out the minimum processing hours from this table. So minimum processing hours are 6 hours. So these 6 hours are required by job E on machine H. So on the side of H, I'll write E. Cut this column, will not refer this column again. Now from the remaining column, minimum processing hours are 8. So these are 8 hours are taken by job F on machine H. So I'll write down this F on the side of H. That is F. Now cut this column. Now from remaining 4 column, minimum processing hours are 9 hours. So I'll write this D on the side of H, as these 9 hours are taken by job D on machine H. So I'll write D over here. Then from remaining 3 columns, minimum processing hours are 11. So I'll select this 11, which will be taken by job B on machine H. So I'll write B on the side of H and cut this column. Now from remaining these 2 columns, minimum processing hours are 12, which are taken by job C on machine H. So write C. Now from remaining first column, minimum value is 13. That is for job A on machine H. So I'll write A over here. Now this is our sequence of operation. That is, A will perform first, then will perform job C, then will perform job B, D, F, and lastly E. So this is the optimum sequence which will give us a minimum total elapsed time. To calculate total elapsed time, draw a table like this, in which first column represent the sequence of job. In second column, machine 1, under machine 1 we have 3 columns, that is in time, process time, and out time. Similarly for machine 2 and 3, we have made columns like in time, process time, out time. Then in last, idle time for machine 1, machine 2, and machine 3. Now in first column, that is sequence of jobs. So whatever sequence we have obtained in last step, that sequence will write down. So the sequence for the operation was A, C, B, D, F, and E. So I'll write down this sequence in the first column. So A, C, B, D, F, and E. is the sequence of operation. Now this job A will be initially performed on machine 1. So in time for this job A is considered as 0 hours. This A job is processed on machine 1 for 12 hours. So in the question table it is given job A requires processing time of 12 hours on machine 1. So processing time I'll write over here as 12. So total out time will be 0 plus 12, that is 12. Now after 12 hours, machine 1 will get free to take job C. So in time for job C will be 12 hours. Now job C requires 9 hours on machine 1. So total processing time for the job C is 9 hours. So out time will be 12 plus 9, that is 21 hours. Now in time for B is 21 hours. Write down 21 over here. Then the processing time of job B on machine 1 is 10 hours. Now total out time will be 21 plus 10, that is 31 hours. Now in time for D is 31 hours. Carry this 31 over here. Then process time of job D on machine 1, that is 14 hours. So write down 14 over here. So out time will be 31 plus 14, that is 45 hours. 45 hours will be the in time for job F, and processing time of job F on machine 1 is equal to 9 hours. So write down 9 here. So out time will be 54 hours. This 54 hours will be in time for job E. So write down 54. Processing time of E on machine 1 is 7 hours. Write down 7 over here. And total time out time will be 61 hours. Now let's do the calculation for machine 2. Now as A job is processed on machine 1 for 12 hours. After completion of operations on machine 1, this job A will be forwarded to the machine number 2. But this job A comes before it comes to the machine 2. Machine 2 has to wait for the 12 hours. So this 12 hours is the idle time for the machine 2. So I'll write 12 hours idle time in machine 2. So the in time for job A on machine 2 will be 12 hours. We'll write down 12 over here. Now processing time of A on machine 2 is 6 hours. So write down 6 here. Total out time will be 12 plus 6, that is 18. Now here you can see that this job A requires 18 hours to complete on machine 2, right? And job C requires 21 hours on machine 1. So after completion of job A after 18 hours, this machine 2 has to wait for some time before C jobs arrive on machine 2. So this total waiting time for machine 2 till the job C comes to machine 2 is 21 minus 18, that is 3 hours. So this 3 hours is the idle time for machine 2. Carry this 21 as it is as the in time for job C on machine 2. So 21 I'll write over here. Now processing time of job C on machine 2 is 6 hours. So carry this 6. Now out time will be 21 plus 6, that is 27 hours. Again this 27 hours are less compared with the 31 hours. So machine 2 has to again wait for 31 minus 27. Right? That is 4 hours till job B comes to machine 2. So 4 hours will be ideal time for machine 2. Now in time of job B on machine 2 will be 31 hour. Processing time of job B on machine 2 is 5 hours. So 31 plus 5, that is 36 hours. Again 36 is less compared with the 45. That means again machine 2 has to wait till job D comes to machine 2. So the total waiting time, that is idle time, will be 45 minus 36, 9 hours. So in time of job D on machine 2 will be 45 hours. Process time of job D on 2 machine is 4 hours. So write down 4 here. So out time will be 45 plus 4, that is 49 hours. Again this 49 is less compared with this 54. So it means machine 2 has to wait again for some time till job F comes to machine 2. So that is the ideal time. So this ideal time will be 454 minus 49 is equal to 6 hours. So this is the ideal time, that is 6 hours. Carry this 54 as it is. Now process time of F on machine 2 is 4 hours. Out time will be 54 plus 4, that is 58 hours. Now 58 is again less compared with the 61. So machine 2 has to again wait before E jobs come to machine 2. So that is the ideal time. So ideal time will be 61 minus 58, that is 3 hours. So I'll write 3 over here and 61 here. Process time of E on machine 2 is equal to 2 hours. So write down 2 over here. Total hours will be 63. Now let's do the calculation for machine 3. See here, now job A will arrive on machine 3 after completion of its operation on machine 2, that is after 18 hours. So the idle time for machine 3 will be 18 hours before job A comes to machine 3. Now write this 18 as in time for job A. Processing time of A on machine 3 is 7 hours. So write 7 over here. Out time will be 18 plus 7, that is 25. Now this 25 is less compared with the 27. So machine 3 has to wait for job C, right? So that is 27 minus 25, that is 2 hours. So 2 will be idle time. Write down 27 here. Now job C will be performed. Job C requires 6 hours on machine 3 processing time. So 27 plus 6 is equal to 33 is the out time. Again this 33 is less compared with the 36. It means machine 3 has to wait till job B comes to machine 3 for 36 minus 33, that is 3 hours. So write down 36 here. The process time of job B on machine 3. Job B on machine 3 requires 6 hours of processing. So out time will be 36 plus 6, that is 42. Again this 42 is less compared with the 49. So machine 3 requires to wait before job D comes to machine 3. Total waiting time will be 49 minus 42, that is 7 hours. So idle time will be 7 hours. Here write down 49. So process time for job D on machine 3 will be 5 hours. So write down 5. Out time will be 49 plus 5, that is 54. So 54 is again less compared with the 58. So machine 3 has to again wait. So waiting time will be 58 minus 54, that is 4. Write down 58 as it is. Process time of F on machine 3. F on machine 3 requires 4 hours. Out time will be 58 plus 4, that is 63. So there is no waiting time, right? As 63 is equal to 63. Write down 63 as a in time for E. So E requires 4 hours of operation on machine 3. So write 4 over here. So total will be 67. Therefore total minimum elapsed time equal to 67 hours.